Good evening. Our main topic tonight is Jupiter, giant of the solar system, now brilliantly visible in the night sky. And we've just come to the end of a very successful Jupiter mission. But first, our constellation of the month. Last month, I talked about Ursa Major, the Great Bear, plough, whatever you call it. And from there, we used the pointers to find the pole star in the Little Bear. On the far side of the pole star, and now high up, is Cassiopeia. In mythology, Cassiopeia was a proud queen. In the sky, she's like a W or an M, reasonably bright. And next to her, her husband, King Cepheus. Not nearly so spectacular, but one very interesting thing there. If you've got binoculars, find the star, Mu Cephei. It's red. So red it looks like a glowing coal, and it's called the Garnet Star. A huge giant star, many millions of miles across, and a long, long way away. Also, news notes. China has become the third nation to put a man into space. On October 15th, Colonel Yang Lewei made 14 circuits of the Earth and landed safely. China has now announced a very ambitious program. I hope they'll join in with America, Britain and Europe. We can wait and see. Also, two interesting asteroids around. In 1937, Hermes brushed past us at less than 500,000 miles and caused quite a stir. It was then lost, and now, at last, it's been recovered. It's faint, of course, but it's been made of two rocks, neither more than 500 yards across, almost or quite in contact. I'm glad to say it won't hit us. And then, on 27th September, an even smaller asteroid, 203 SQ222, went by at less than 50,000 miles. I'm glad to say that went this hour. Anyway, it's less than 20 feet across. And now, on to our main theme. Jupiter is the giant, nearly 90,000 miles across, and going around the Sun at a mean distance of nearly 500 million miles. Its year is nearly 12 times as long as ours, but it has a very short day, less than 10 hours long. And it is a gas giant. We're not seeing a solid surface, we're seeing gas. And Jupiter is huge. And within an hour, I'm delighted to welcome Dr. John Rogers and Professor Garry Hunt. Now, Galileo has come to a spectacular end, deliberately, and it's been a very successful mission.
It has indeed. It's produced a lot of data about Jupiter and its satellites. It was launched in 1989. It took 6 years going round and round the solar system in order to build up enough energy to get to Jupiter. And then it arrived there in December 1995. And the mission had two components. There was the orbiter, which went into orbit around Jupiter, and there was the probe, which was the first man-made object ever to enter the atmosphere of Jupiter. And so those both arrived on the same day in 1995. The probe lasted about an hour, and the orbiter has been in orbit sending back data for the next 7 years.
Well, during its descent, the probe told us a great deal about Jupiter's atmosphere, didn't it?
Well, we learned a lot about the atmosphere, but as a mission as a whole, it's really spectacular. You need to put the whole thing in perspective. This has actually produced about 30 gigabytes of data, a massive amount of data, 14,000 pictures. But if you really want the idea of how it worked from a conservational point of view, it had actually a fuel consumption of 11 million miles to the gallon. So it's a pretty spectacular spacecraft in that sense. In terms of the atmosphere and the probe, yes, we've started to have a chance to send a probe in directly from the mission, as well as observe, obviously, a cometary encounter. It's raised a few questions, understanding the distribution of the water vapor, particularly in the place where the probe took place. But opportunity to, again, to follow on the mission of Voyager before it, of looking at the turbulent cloud motions. And the meteorology is still not understood. It's highly complex, mixing with the chemistry with the vivid colours.
And of course, when we look at Jupiter, one famous feature is the great red spot.
Yes, indeed. Well, this is a giant anticyclone, similar to anticyclones on Earth in some ways, but on a far larger scale and far older, because in the atmosphere of Jupiter it can circulate for centuries without running down. The red colour can be quite spectacular at some times, so at the moment it's a rather pale reddish colour, but it's always visible in some form or other through amateur telescopes. Everything that we see on Jupiter is cloud patterns because the atmosphere is deep and energetic with huge winds. And the fascinating thing about the planet is that the wind sculpts the clouds into huge weather systems on a scale larger than those of Earth, very well organised, repeating in patterns over years or centuries, but always coming up with something unexpected as well.
What are the main gases? Hydrogen, of course.
Hydrogen is the main one, helium is the next most abundant, and then there are all the simple compounds of hydrogen, such as methane, ammonia, and water. And the clouds are thought to be made out of these molecules and some of their compounds.
Some of the spectacular things we've seen are a large number of thunderstorms. We saw thunderstorms before at Voyager, but here during Galileo we'll be able to see them quite repeatedly, some quite close to the red spot itself.
And on the way, one very interesting event, a comet, Shoemaker-Levy 9, crashed into Jupiter, and only Galileo could record it.
Yes, you can actually see the flash in some of the Galileo images. The Hubble Space Telescope could see the plume, the fireball erupting over the edge of Jupiter, and astronomers on Earth could see the dark deposits of soot that were splattered over the surface afterwards. It was a very exciting week for all astronomers, whether amateur or professional.
I saw the results, even with the finder of my little telescope.
Yes, those were the blackest, biggest spots that had ever appeared on Jupiter.
And they lasted for some time.
Yes, there were still some traces of them a year later in terms of a belt that had been smeared around the southern hemisphere of Jupiter.
You know, even in my lifetime, it was thought Jupiter might be a miniature sun, sending out a great deal of heat. It's not like that at all.
Well, it does emit some heat. Now, of course, the cloud tops that we see are in fact very cold. And the weather systems that we see are composed of frozen ammonia, frozen crystals of vapours. But there is heat coming from inside, and it's thought that that's what drives a lot of the motions. So the motion of the Great Red Spot, for instance, that endless circulation, is largely driven by heat emerging from the interior of the planet.
But of course, Jupiter is a dangerous place with a very strong magnetic field and zones of radiation.
Well, they're absolutely huge, and I think it's the whole thing to realise that any spacecraft going there has got to somehow navigate its way through this enormous area of trapped radiation. And the very first time you and I did television together, 30 years ago, we were talking about the pioneers, and they were arcing as they went through those areas. So Galileo, in his repeated orbits, he did 35 orbits around Jupiter, was constantly going through, and it's had 4 times the dosage of radiation as expected, and it had to somehow withstand these highly charged particles in this area which pulsates with effects taking place in the sun, and embedded within that are the major satellites as well. So all of the environment is affected by the charged particle area around Jupiter.
Of course, Galileo had been responsible for 2 impacts. First of all, a deliberate impact when a probe was released and went into Jupiter's gas, with rather surprising results.
Yes, indeed. People knew what they expected to see in terms of the gases present and the cloud layers, but there were surprisingly few clouds and surprisingly few vapours. Now, we think that was because the probe went into a very dry region, a very special weather system on Jupiter. These are actually weather systems that we can see clearly from Earth. They're great dark spots close to the equator. And it was just by the luck of celestial dynamics that the probe went into one of those. And so the Galileo team have spent some time observing those from orbit to try and figure out why they are so special. They're now beginning to understand how these are great waves with a deep downdraft in them. And so the Galileo probe findings, in fact, are consistent with the previous models of the atmosphere. But it just goes to show that a single observation in science doesn't give you a complete answer to a problem.
This is absolutely the point. It's a great pity we didn't look at higher latitudes, different parts of the planet, because one of the things that really puzzled me and many other people was, where's this all water vapour gone? This is absolutely fundamental for driving the weather systems. It'd been wonderful if you could put something at the top of one of these massive spots, Great Red Spot being a wonderful place, but that was just one arbitrary location we were chosen. But it did give us some information, some surprises. The absence of water vapour was clearly one that was a great surprise at that moment.
And now Galileo itself is no more, deliberately crashed into Jupiter.
Yes, well, the reason they did this was so that it would never crash into one of the satellites, in particular Europa, because it was almost out of its fuel, so it would no longer be possible to control it. It was hardly capable of sending back data anymore because of the radiation dosage it had experienced. So this seemed like a fitting way of cremating it at the end of the mission and making sure that nothing bad ever happened.
Well, the satellites, after all, with any small telescope, you can see the 4 Galileans, Io, Europa, Ganymede, and Callisto. And they're all planetary-sized worlds, called the Galileans because they were observed by Galileo way back in the year 1610. And somebody once said, there's no such thing as an uninteresting Galilean. And that is true, isn't it?
Well, it certainly goes back to the last few years in the take Voyager. We were surprised what was going to be when we found with the satellites then. I think the observations now with Galileo have really put a new dimension to what takes place. The discovery of the volcanoes on Io the first time was one thing, but now to be able to see the time variation of them, and there are enormous temperatures in some of these volcanoes. We're talking about 1700 degrees Kelvin inside some of these calderas. They're enormous, and the whole satellite is bathed in active volcanoes, putting sodium into the atmosphere, and we're to altitudes of about 1 kilometre or so. So it's a very strange place, and explains the first thing that was the puzzle some years ago of how smooth the surface was. And we now see that's the reason.
Well, also, Io moves right in the middle of Jupiter's lethal radiation zone, so I don't fancy going there. Activity is going on all the time.
Indeed, and Galileo actually flew through one of the volcanic plumes. In its later encounters, the mission engineers became more and more daring in sending it deeper into the radiation belts and closer to Io. And also, fortunately, during the last few years of the mission, Io produced a few really enormous volcanic eruptions that hadn't been seen in the earlier missions. So an enormous great plume was seen, and at the next encounter, it was hoped that Galileo would fly through that plume, which apparently it didn't because the plume had stopped erupting, but it flew through a different one that was just a little way south, that had arisen quite unexpectedly.
Well, Io is just slightly bigger than our moon. Number 2, Europa, is very slightly smaller than our moon and a totally different kind of place, an icy surface and possibly an underground sea.
Well, I think in the case of Europa, it looked like an eye. It was a strange body when it first seen by Voyager, and then these strange, long, linear features. And it had instant and constant question marks. And as Galileo has gone on to higher and higher resolution pictures, we can now see there was an awful lot of structure there, and the interpretations with the other results, particularly the magnetometers and such like, has suggested that we may have a situation that we have a crust over an ocean. So we may have some sort of briny ocean taking place.
An ocean of ordinary liquid water.
Well, it could be a bit salty, but certainly something which is very strange. And also you see the colorations that take place in some of the pictures, and that's because there is a natural colour of the blues, and then once you had impacts and other motions taking place, material will be thrown out, and as it vaporizes, the chemistry changes, and you get these interesting reds and blues around the surface of the satellite.
What about the temperature of this underground ocean?
Nobody really has an idea. We only speculate. And I think at the moment, even how far beneath the crust that ocean is speculation. So I think at this moment we can say there is something very important there. The cremation of Galileo was done because we wanted to make sure that nothing in the environment was affected by anything man-made. So any subsequent missions, and indeed we hope there will be ones to Europa, will be going to look at Europa as it is and as it's been developed by all that's around it.
John, how confident are you that there is an ocean there, and how do we know?
Well, the evidence is pretty good now. It was first inferred from the Voyager images, because there you could see global patterns of lines across the surface.
Icebergs?
They must have been cracks in the ice. And it was known that there was an ice crust, and that was clear from Voyager. And it's very hard to get global patterns of sharp lines like that unless the ice crust can crack and respond to tidal forces as a unit, detached from solid material below it. Galileo produced much better evidence in favour of an ocean by looking at high resolution at the surface, where indeed you can see regions where it looks like icebergs have been drifting around. We don't know if they were drifting around literally in water, or, as most scientists think, perhaps in slushy ice, like icebergs moving with glaciers. And then the third piece of evidence, which clinches it for many scientists, is this magnetometer evidence that as Galileo flew very close to Europa several times, it discovered that the magnetic field around the satellite seems to be changing. And that is happening because Europa is moving through Jupiter's magnetic field, and that causes currents in any liquid that may be down in the satellite. And the fact that those changes were seen by the magnetometer suggests that there must be a global ocean deep down in Europa.
Then we come to Ganymede, number 3, actually slightly larger than the planet Mercury, and Ganymede has its own magnetic field.
The fact that Ganymede has a magnetic field is a big question. It's not been talked about enough for my liking. A little while ago we were talking about Mars and said, what's about the magnetic field on Mars? Here is a satellite with a magnetic field. Suppose there's another one in the Saturnian system. That to me is a very spectacular observation, because the people who are putting forward the theories about dynamos or rotational bodies have got a question to ask here. It will say a lot more about the structure of Ganymede, but also its chemical composition. That is a very important question that needs to be understood.
And then we come to the outer Galilean, Callisto, nearly as big as Ganymede, with an icy surface again, and absolutely crammed with craters.
But some smooth spots. I think this is the thing that, again, was a surprise. It looked at the resolution of Voyager to be wall-to-wall craters, but the higher resolution of Galileo has found some areas which are smooth. So there are obviously processes taking place. They may be ejected material, but so it's not as straightforward as people have detected and suggested in the past. But the important thing about this set of 4 satellites, how different they are from the very active volcanism on Io, perhaps the oceans on Europa, the magnetic field on Ganymede and Callisto, with a mixture of perhaps a vast amount of craters, but some areas of smoothness. A fascinating world.
The surface of Callisto makes it appear that all the craters have been eroded over billions and billions of years. So you see pinnacles of ice sticking up over a mantle of dust that shrouds most of the surface.
But what's interesting here, you mentioned the magnetic effects on Io from Europa. Well, you get the same with Callisto, don't you? There can be an ocean there too.
Apparently so. This was most unexpected because all the models suggested that Callisto would be solid, mixed ice and rock all the way through, never melted in its entire history. On Ganymede, there is evidence that it was melted because the crust was active many billions of years ago, but nobody expected a magnetic field or an ocean in either of them nowadays. But the magnetometer does suggest that there is extensive liquid water deep down in Callisto, and therefore there would be likely to be the same in Ganymede as well.
Well, Jupiter has an amazing family, and also, of course, Jupiter has rings, but they're not like Saturn's.
No, they're very diffuse, very thin, and obviously there's some of the smaller satellites are spread out there, obviously created a lot by the material that's moving around, has been thrown off from some of the satellites as well. Again, a surprise observation from Voyager, but Galileo's had a chance to see them much closer up and see the number of embedded tiny bodies there as well. But certainly it's being populated by material that's being spun off from a lot of the neighbouring satellites, as well as material perhaps dragged in as well.
Well, Galileo is now over. What are your closing thoughts, Garry?
Well, not only a fantastic mission, and one I'm pleased with the success they've had. Surprises, I think the greatest surprise, I would say, was the magnetic field around Ganymede, and seeing that explained in conjunction with magnetic fields in general would be a tremendous advancement. And of course, we've got to go and have a good look at Europa.
Well, I think as in the sky, your main interest on is Jupiter. So what do you make of Galileo?
Well, it's told us what some of these weather systems are that we have been looking at for so long. We can see white spots erupting on the surface, and now we know that those are the great thunderstorms, for instance. But we can carry on observing it with great pleasure because there's always something happening on Jupiter. One can always see new weather systems developing and moving. One can see patterns working out in the atmosphere over weeks or over years. And so there's always something there for amateurs to observe.
Galileo is no more, but the Cassini mission on its way to Saturn is operating well, and it bypassed Jupiter and sent back some very interesting results.
Yes, indeed. While Galileo could only focus on individual features and send back a fixed number of photographs, Cassini was able to monitor the whole planet for several weeks and take these beautiful movies which showed the atmospheric motions in better detail than had ever been seen before.
And certainly there were some surprises, were there not?
Yes, indeed. And one of the most visually impressive surprises was the aurorae seen around Io. It took this movie showing Io in complete darkness in Jupiter's shadow, but what you see is the glow of aurorae flickering to and fro around the edge of Io as the emissions from Io's volcanoes interact with Jupiter's magnetic field. And you can also see bright spots, which are the volcanoes themselves glowing in darkness.
Well, what next in Jupiter research? What things are to come now, after Galileo?
We've got to go to Europa. It's peculiar. It's very odd. We have no idea what's there. There's more conjectures than there are degrees of understanding. And we've wisely done the right thing. We've got rid of Galileo, so it's not going to contaminate the environment for having a good look at Europa in the future. That's got to be the place to go.
Well, everyone's talking about life in the oceans of Europa, and frankly, I'm highly sceptical.
Oh, I think there could be life there, but I wouldn't put a bet on it.
No, no, no.
Well, I don't think we'd recognise it if we found it. I think it's always one of the things that can distort, in fact, be damaging for the space population to actually say that. There's lots of peculiar basic processes we don't understand. Let's go and look at it at Europa.
Gary, John, thank you very much.
Thank
Thank
you.
you, Patrick.
Well, meanwhile, Jupiter gives us plenty to think about, and it is now there to be seen on the night sky, with the belts, the spots, and the Galilean satellites, and following round Saturn their system of rings. To me, the loveliest object in the entire sky. Don't forget our webpage, www.bbc.co.uk/space. When I come back next month, we'll talk about something entirely different. We may, I say may, have 2 fairly bright comets next year, so comets will be our main theme. I'll be joined by Mark Kidger. So until then,